Thank you, Adi. Hello, everyone. I'm very excited to be a speaker today and being able to connect with so many of you at this event. I have a packed agenda to go through the session today, and hence I'll be looking at the slides during my presentation. I will not be able to see the chat and can get to it only towards the end. A little bit about me. I'm Aggarwal. I have 20 plus years of experience in different engineering roles, and I'm currently working as an engineering manager at Google India. You can connect with me on social media platforms, the details for which I have shared on Hopin profile page and also here. So let's quickly see what is accessibility. Accessibility refers to the design of products, devices, services, or environments so as to be usable by people with disabilities. Sometimes you will see A11Y written, so it's a neuronym presenting accessibility. It consists of A followed by 11 more letters followed by a Y. So who are our accessibility users? It could be people with different abilities, the elderly or the kids who may not be able to perform all activities, or it could just be you and me. We're talking about accessibility in today's session as this work is important because globally there are over 1 billion people who have disability and 6 billion people who are temporarily able-bodied, meaning someday they will have a disability. If products are inaccessible, intentionally or even unintentionally, billions of people are put into potentially stressful situations and there is no inclusivity. They need to be able to achieve the same goals as everyone else. However, they may use different mechanisms to achieve the goal than the commonly understood approach. In accessibility, community, and in the context of today's presentation, we focus on 4 accessibility personas, people having challenges with vision, hearing, mobility, and cognitive or learning disabilities. This is not an exhaustive list, but it's a good start. Let's look at the different personas for one particular disability with vision. To illustrate this concept, every person in this session has a different relationship with limited vision, whether permanent, temporary, or situational. A permanent disability could be that you are completely blind, or you may temporarily experience a disability like vision loss, or when you have a migraine headache, or you're searching for or reading something very, very small. And trying to read the board with the bright sunlight glare is a great example of experiencing a disability in a limiting situation. As you can see, there are a number of assistive technologies. Some of you may be using and benefiting from some of these technologies, such as large font, magnification, the pinch to zoom or browser zoom, captions, voice input, the basic keyboard, and even autocomplete. This is no way an exhaustive list. While this list of assistive technologies may seem overwhelming, the good thing is that most assistive technologies inherit their behavior from 2 basic technologies, the keyboard and the screen reader. A solid foundation of support for these user experiences trickles down to other assistive technologies. There are different ways of measuring how accessible a product is, and there are some standards and guidelines defined for us to refer to. In the US, federally funded institutions are required to comply with the civil rights legislation of the Americans with Disabilities Act and Section 508 of the Rehabilitation Act. Section 508 is US federal civil rights legislation, which states your electronic product must meet a minimum set of accessibility standards. The federally funded agencies or programs might evaluate products based on accessibility, so they are not discriminating against people. The standard that most developers rely on is Web Content Accessibility Guidelines. It was developed by the World Wide Web Consortium, the same international group that defines all the standards of the internet. And last but not the least, we have VPAT. A VPAT, or the Voluntary Product Accessibility Template, is a document that allows a company or an organization to provide a comprehensive analysis of the product in conformance to the accessibility standards set by Section 508 of the Rehabilitation Act. Now let's start with the content for this presentation. That was the intro. Focus on keyboard. Here we will look at how we can make sure we build things that can be operated with a keyboard. This is important for users with motor impairments, but also ensures that your UI is in good shape for the semantics. And also not necessarily for only for people with a disability. The power users who know every keyboard shortcut on the machine mostly use the keyboard to quickly navigate through the site. Thus, a well-implemented focus strategy ensures that everyone using your application has a better experience. Semantics is where we make sure that we are expressing our UI in a robust way, which works with a variety of assistive technologies. When we have built a web application, we test it by navigating through the elements of the page using keys on the keyboard. For example, can you move to the next element with the tab key? All the actions you perform using voice or mouse, can that be performed using just the keyboard? The order in which focus proceeds forward or backward through interactive elements via tab, it's called the tab order. Ensuring that we design our page with a logical tab order is important, and we will see why. Here I have simple HTML button elements with different labels. I'll just put up my pen here. To learn about focus behavior, because they are automatically inserted into the tab order based on their position in the DOM. As you can see, the sample output on the right. So here we have three buttons in the DOM order, and here we have exactly the same output. Now, when I press the tab key, the focus moves to the first button on the screen. I hit enter, and then my focus is on the second button on the screen, and then to the third. Built-in interactive HTML elements like text fields, buttons, and select lists are implicitly focusable, meaning they are automatically inserted into the tab order and have built-in keyboard event handling without developer intervention. But not all elements are focusable, like paragraphs, divs, and various other page elements are not focused as you tap through the page, and that's by design. There's generally no need to focus on elements like paragraph because the user has nothing to interact with it. Now let's use a CSS property like float to move one button to the right. Buttons appear in different order on the screen now. Let's see what happens. The first tab, when I enter the first tab, where does it go? The first tab goes to the rightmost element, which has the first. So it is still, so the tab order is still following the DOM order. DOM means the document object model. But because their DOM order in DOM remains the same, so does their tab order. When the user taps through the page, the buttons gain focus in a non-intuitive order. We must exercise extra caution when changing the visual position of elements on screen using CSS. This can cause the tab order to jump around and can confuse users who rely only on the keyboard. Ensure that the reading and navigation order, as determined by the code order, should be logical and intuitive. We just saw how focus works on simple component like a button. Managing focus on a page when you're navigating is really important. If you're building a custom select element, you will have to ensure that the focus at the component level is also working. You have to expose the same kind of behavior so users who are relying primarily on the keyboard could still interact with the component or control. For tab index to work in a group of radio buttons or combo list, you can set the tab index to -1 for the children and 0 for the currently selected item in the list. The component relies on the keyboard event listeners to determine which key the user has set and at what point we can set the tab index as 0 for the previously focused item. A skip link it's an off-screen anchor that is always the first focusable item in the DOM or a web page. You can use a simple anchor tag and a class for skip link to navigate to the main content. Else the user will have to tap through all the links in the heading and off-screen content and the sidebar before coming to the main content of the web page. This is essential when you think of a user with motor impairments who probably might be using a switch device. You can find all this information on what kind of keyboard interaction is expected from a particular component in the ARIA 1.1 design patterns and widget site. You can find the full list of various kinds of components here. We'll talk about ARIA in the upcoming slides. Off-screen content. A responsive drawer panel is a very good example of off-screen content. It is a very common UI pattern. This one you can see. But when it comes to accessibility, it can pose an interesting challenge. In that case, what we need to do is to ensure that the tab focus doesn't move to the off-screen content. To do that, we need to set the visibility as hidden and display as none. And when the off-screen content is about to come on screen, you can change the visibility to visible and display as block. Sometimes a keyboard trap may be desirable when a modal appears. Let's say you're working and suddenly a calendar reminder pops up. So the tab can move through the modal dialog, but can move back to the main content in 1 or 2 tabs. So that's how you implement modals. Semantics and assistive technologies. Here we will talk about another type of assistive technology, and that is the screen reader, a program that enables visually impaired people to use computers by reading screen text aloud in a generated voice. The user can control what is read by moving the cursor to a relevant area with the keyboard. Let's see this example here. I have a sample student enrollment form with a few native elements. A screen reader actually creates a user interface for the user based on programmatically expressed semantics. So instead of a visual UI, the screen reader gives some more information about the element. Specifically, what type of element is it? I mean, what is the role of this element? So the role can be edit text, combo box, checkbox, radio button. So these are the different roles. Then what is the name? Let's say student ID, batch. So this is the name of my element. And what's the state? Whether it's collapsed, checked, that's the state. And we have value. Value means what is like here in this combo box, 2020, 21 is selected. So that's the value here. For most part, we are going to call the name as label. They both mean the same thing, but in HTML context, it's much more intuitive to see the label. Here we have shown how we have defined our checkbox. We have put the type as checkbox and within the label element, and the status is checked. Since these are native HTML elements, the screen reader will read it as host role accommodation required checked checkbox. And that's the desired one. Another way of representing the same thing will be with the help of ID and for elements. So here you can see I have written the input element, and somewhere below at a different place in the DOM tree level, I have label. So it's connected, like ID is account rec and here for account rec. So these two are still connected and your output will still be the same. Talking of labels, we have two types of labels, visible and invisible. Visible labels, as in case of this button, where it shows that its label is submit. Whereas on the right-hand side, there is an image where if you haven't specified anything, the screen reader might just read as img31057.jpg. And that might be very frustrating for someone who is visually challenged. So in the image tag, along with source, we must mention the alternative text with the alt tag. So the screen reader can announce it as a cup of black coffee. But there can be instances where we do not want the literal name of the image. For example, for the search link, if you have specified the alt text as magnifying glass, the screen reader is going to read it as magnifying glass search link. Which is probably not required, as the image is there only as a visual cue. So what you should do is you can leave the alt text as null and the screen reader reads it as search link. Accessibility tree. Let's see the same student enrollment form example. Now imagine if you have to build the same UI for screen reader users only. So you do not have to create any UI at all. Just provide enough information for the screen reader to use. So how would you express the form interface for this particular form? Well, what we would be creating is kind of an API describing the page structure, and that is kind of the DOM API, but with much fewer nodes. It would appear something like this. So here you have the form level, main, and these are at the different child levels. So this enables the screen reader to jump between the high-level sections and then get through the information about each of these form element affordances to know how to fill them in. For the user, the screen reader provides the affordances based on the role alone without caring about the visual style. For example, for button, it knows that it needs to be clicked. So this is what the browser actually does present to the screen reader. I have just taken the last three elements of the screen, so the font is legible here. Now, what happens that is when the browser takes the DOM tree and modifies it to turn into a form which is useful to assistive technology. Now you can see the div tags, the breaks and span, all of this is not required for assistive technology. Assistive technologies move from main to form to different elements directly. So all of that is of no use. So we refer to this modified tree as the accessibility tree. The accessibility tree is what most assistive technologies interact with. A browser can transform the DOM tree into an accessibility tree. Whenever possible, use semantic HTML and native form controls. The native elements give you keyboard support, focus, and built-in semantics for free. However, there are situations where we cannot use native elements, and that's where ARIA comes to rescue. Let's see in the next section. I already showed like where the div elements were ignored by the screen readers. Web Accessibility Initiative and accessible rich internet applications are good for bridging areas where native HTML can't be used to address accessibility issues. Why ARIA or simply ARIA works by allowing you to specify attributes and elements that modify the way that element is translated into the accessibility tree. Let's look at an example to see how this works. As shown in this example, if you create a plain checkbox, we, users of our assistive technologies like VoiceOver, will be able to operate it. The screen reader will announce it as a checkbox, tell you that it has a label, and whether it's checked, whether its status is checked or not. But what happens if for some reason we decide we need to re-implement this basic checkbox differently, either in a div tag or a list item, or maybe somewhere else, or maybe on an image too. Not on an image though. We know that it should be focusable and should be able to handle the same keyboard interactions as a native checkbox. But what happens when we then start using it with a screen reader? The screen reader gives us no indication that the element is meant to be a checkbox. Sighted users can see that the visual cues to understand that it is a checkbox, but there won't be any announcement to the screen readers when we are using it inside the div tag. And the assistive technologies completely ignore the div tag. Now, using ARIA allows us to tell the screen reader that there is some extra bit of information here. So ARIA attributes always need to have explicit values. Adding that role and ARIA checked attribute causes the node in the accessibility tree to have the desired role and state without changing anything else about that node's appearance or behavior. To reiterate, the only thing ARIA modifies is the accessibility tree. It does not change the behavior of the element, appearance of the element. It's not going to make the element focusable, nor would it add any keyboard listeners to the element. ARIA can add semantics to an element when no native semantics exist. For example, the div element that has an explicitly and deliberately no defined semantics. So these are the two ways. So this is how, if you implement inside the div tag with ARIA checked, the screen reader can understand that yes, it is a checkbox. ARIA can also modify existing element semantics within bounds. For example, I can use a button element to demonstrate an on-off kind of switch. I can use an ARIA role of switch to a button to express more accurately its semantics. Often ARIA lets us create widget type elements that wouldn't be possible with plain HTML. For example, ARIA can add extra label and description text that is only exposed to assistive technology APIs. Here in this example, you have a hamburger menu, but there is no label inserted. But since we have put up an ARIA label, the screen reader is going to read it out as a menu button. In this case, we have an ARIA label and there is a label to the button, which is X. When you have a button label and an ARIA label, ARIA label takes precedence. So the screen reader is going to read it as closed button. A little bit about labeling. ARIA can read extra label and description, which is only exposed to assistive technology APIs. You just saw in the previous slide that if a button has both text content and an ARIA label, only the ARIA label value will be used. ARIA labeled by. This allows us to specify the ID of another element in the DOM as an elements label. It's usually used for relationship attributes. And ARIA described by is very similar to ARIA labeled by, where a label describes the essence of an object, a description provides more information that the user might need. ARIA labeled by overrides all other name sources for an element. So for an example, if an element has both an ARIA labeled by, an ARIA label, or an ARIA labeled by and a native HTML label, the ARIA labeled by label always takes precedence. It's kind of a tongue twister now. These are the different ARIA roles possible, and for a taxonomy of possible values for the role attribute and associated ARIA attributes that may be used in conjunction with these roles, you can refer to the ARIA spec. That is the best source of definitive information about how the ARIA roles and attributes work together and how they can be used in a way that is supported by browsers and assistive technologies. An interesting capability from ARIA spec is that ARIA can make a part of the page live, that is in the form of assistive technology right away when they change. In case of an alert, the screen reader might choose to immediately speak to the user, interrupting whatever they are doing. ARIA Live has 3 allowable values: polite, assertive, and off. So ARIA Live polite tells the assistive technology to alert the user to this change when it has finished whatever it is currently doing. Let's say the user is sending a message, so it would let the user send the message and then display it. It's great to use if something is important but not urgent and accounts for the majority of ARIA Live use. ARIA Live assertive, it tells assistive technology to interrupt whatever it's doing and alert the user to this change immediately. This is only for important and urgent updates, such as a status message like there has been a server error and your changes are not saved. Please refresh the page. ARIA Live off tells assistive technology to temporarily suspend ARIA Live interruptions. These are some of the attributes that can be used with ARIA Live. In the interest of time, I'm not going through these for now. Navigating with a screen reader. Let's see. So we looked through headings, links, form controls, and there are different landmarks which are there on a web page. So how would you navigate your web page with a screen reader? So I'm going to give you a quick demo, which I've recorded, and it's using a screen reader. I'm using the VoiceOver in the Mac operating system here. VoiceOver has a tool called Web Router that allows to navigate and choose through headings link. Headings make it easier to navigate through the page. And one thing you would notice in this demo is the order in which the headings in the Web Router are different from the order you see in the web page. The order is more logical on a router. It will talk through the heading levels like H1, H2, H3. Indicating, so H1 will have more prominence on the page than an H2, and H2 will have more prominence on the page than H3. So the next time you are putting up a heading, put it as heading because that displays the prominence on the page. Don't put it as a text in a bigger font. So you know what would be important for the voice reader. So let's quickly look at this. Here you can see we are navigating between different types of elements. You can see the headings are ordered, like heading 1, 2, 3. Now we would search for a particular text. I'll just skip this description for now. So that's how, I mean, I use, on Mac, we use Command F5 to invoke VoiceOver, and then Command F5 to again close it. And this is how someone using a screen reader is going to navigate through different headings and different form elements that you see on the screen. The visual representation will be very different from the way the screen reader provides the headings to them. So an H2, which might be at a very bottom section of your page, would still appear higher in the navigation hierarchy. HTML5 introduced some new elements that help define the semantic structure of the page. These elements specifically provide structural clues in the page without forcing any built-in styling. Semantic structural elements replace multiple repetitive div blocks and provide a clearer, more descriptive way to define the page structure for both authors and readers. For example, here, main. Main represents the main content of the page. The header can be a page banner or a group of elements for any introductory content at the start of any type of section. Footer can be a page footer or footer to a particular section or site. Nav represents the section of a page that links to other pages like the top nav bar, or to other parts within the page like a table of contents. Article is for self-contained sections of content like a blog entry, news article or so. Section is a completely generic section of a document or application. A section on its own may not make much sense, so we can include a heading inside as well. Aside. Aside represents any content that is tangentially related to the content around it. In the context of this example, it would be a small pullout or the sidebar. You can also use aside as a page sidebar containing some extra information about the page. The same elements that you saw in the previous slide, you have the ability to implement all of this using ARIA roles. So we have the option of using ARIA roles for defining the landmarks within a div tag, list item, or span, and apply appropriate styling for a visual cue. Let's talk about styling in detail in the next section. In the previous section with the button example, we saw that anytime we focused an element, we relied on the built-in browser focus ring to style that element for us. But sometimes the default focus ring may not fit very well with the design of a page. Maybe the focus ring color merges with the page background. In that case, we can use a focus pseudo class. The focus pseudo class can be matched when an element has focus. You can use the outline property to change the appearance of the focus ring as shown in this example. You can add the same focus class, pseudo class for a button element as shown here. So let's say when your focus comes onto the button, this is how it should show up. If you want the appearance to be same when you hover the button or just focus on it, you can write it in this way, hover, focus here. Sometimes developers choose to put the outline attribute as 0. It is an anti-pattern, as without a focus ring, it is difficult for users to tell which element they are interacting with. If we are removing the default focus ring, then we must replace it with another consistent focus indicator. So keyboard or switch device can navigate your page. In this example, within the focus pseudo class, we are changing the color of the box shadow. Design with a responsive grid. Designing with a grid means your content will reflow when the page changes its size, and it would also work for those of us who need to zoom in the page in order to read similar text. So let's just see. So this is a video. So what I'm doing here, I'm just squeezing the page. So now you can see is the mobile version of the site. Because the page was designed responsively, the UI has rearranged itself for the smaller viewport. Now I'll take another example where if I want to zoom the text because I want bigger font to be there, I can zoom in the content to, let's say, 300%. And again, the content reorganizes itself to some kind of a mobile view. We'll quickly decrease the font so you can see how the original web page was and how it appeared to you. A responsive design is very important for a great multi-device experience. Responsive design also complements the efforts for accessibility. The meta viewport gives the browser instructions on how to control the page's dimensions and its scaling. Width equal to device width tells the viewport to match the screen's width in device-independent pixels. And initial scale equal to 1, we are establishing a one-on-one relationship between CSS pixels and device-independent pixels. These responsive layouts are usually produced using relative units like percentage, em, and rems instead of using hard-coded pixel values. Touch target. Touch target means your application has icons or elements that are spaced and easy to press without accidentally overlapping onto other elements. 48 device independent pixels should be the target size of touch element. 48 pixels is device pixels is around 9 mm by 9 mm, which is similar to someone's finger pad. There are an estimated 285 million people in the world who are visually impaired. This includes anyone who is legally blind to anyone who has less than 20/20 vision. WCAG 2.0 has outlined accessibility specifically with foreground and background contrast when it comes to text. So these are the minimum acceptable contrast ratios for text and images, and for larger text, 3:1 is the minimum contrast ratio. So we'll see quickly an example as to how you can check the contrast ratio issues that are there in your web page. So here's a website. I'm in a Chrome browser. I click Developer Tools. I go to the Lighthouse tab at the top, and we generate a report only for accessibility here, for the desktop version, let's say. So it gives you an accessibility score, let's say 87, and it will tell you what accessibility issues you have in your web page. So here you can see background and foreground color contrast issues are there in these many elements. You can click on those elements and figure out the next course of action of fixing it. I'm just showing an example here. So for a white background color, if the text color is green or these are the different shades of gray, how the contrast ratio changes. So if it is 4.5, it's considered AA, and if it is 7, it's considered AAA, which is really good. For the text in the slide, I have used this gray shade, which is 10.49, and it is accessible. So anything which is below 4.5, it fails the contrast test. So the Chrome browser extension, which we saw, and when it tells you that there is a particular color contrast issue, you come to the element tab, you hover over that element, and it will show you exactly which color is there and what is the contrast ratio here. If you pick another color, it will tell you the contrast immediately right there. Testing for accessibility. So how would you approach testing for accessibility? I showed you earlier how to use Chrome developer tools for testing. Look for different use cases or scenarios the user will be going through and check if you are able to do the required activities with the constraints listed here, without sound, without color, and other things. Always keep in mind those 4 accessibility personas, and which we saw in the initial slides. To address hearing-related deficiency, ask yourself these questions. Is any information conveyed only by sound? any positive dings or negative clinks that are not conveyed by visual or haptic feedback, any audio file streaming that needs transcripts, any video that needs subtitles. For testing for vision related concerns, check if there is any information that's conveyed only by color. Are red and green sole indicators for a status or an action? Is my design going to handle a variety of font sizes or bold font? Think about the layout here. For mobility related deficiencies, consider this. Since switch support depends on voiceover, did I do a good job and complete job there? Is element traversal on the screen working correctly for all screens? Are my touch targets large enough to handle big fingers or elderly impressions? And for motor or learning disability, you must check, is the application navigation straightforward? Are the screens overcrowded with data and actions, or are they clear, prioritized, and streamlined?